Okay, hello everyone. Sorry I'm not here today. I have to take my son to the doctor's. He's fine. It's just a checkup. Uh, so we have 1 unit left to go over before our culminating test. Remember, culminating part one will be tomorrow. It's on linear systems, analytic geometry, and trigonometry. Those are units that's on. Part two will be on Thursday, which is polynomials, quadratic functions that we've done, and now solving quadratic equations. Okay, so when we talked about this unit, the first thing we talked about was solving by graphing. So before I get into that, solving quadratic equations. What it means is to find out set y equals to 0 and find the root. Okay. And the roots of the quadratic equations are just the x-intercepts. So when we say that we're solving quadratic equations, we just want to find the x-intercept, whether it's 1 or 2, or it could be none. We'll talk about that in a second. But that's what we're doing here. Okay, so the first method we use of the three is, was solving by graphing. Okay, so we graph the quadratic equation and look for the x-intercept. Okay, so that could be given to you in standard form, and you have to complete the square to put into vertex form, or it could just be given to you in vertex form. Just to save a little bit of time, I'm going to go y equals -2 x minus 3 squared plus 4. So it's already in vertex form. So it makes it easier to graph. So remember, when we graph parabolas, we always start at the vertex. My vertex is +3, because you know the brackets, and 4. So I'm at +3 and 4. I have my vertex right here. And then I want to do an over-up chart. Over, up. So it'll go over 1, up 1, over 1, up 3, over 1, up 5. Remember, that's the pattern. Unless we have an a value. I do in this case, it's -2, so I want to multiply everything by -2. Okay. Sorry, this is not the equation I want to use. I want to use. Sorry, that's the wrong equation. +8. My vertex is 3 and 8. So I wrote down the wrong number. Okay. Minus. Okay. So instead of going over 1, up 1, over 1, up 3, over 1, up 5, I'm going to go over 1, up -2, which is actually over 1, down 2, over 1, down 6, over 1, down 10. Okay. So I start at my vertex, and I go over 1, down 2, over 1, down 6, over 1, down 10. And same for the other side. Over 1, down 2, right here. Over 1, down 6, over 1, down 10. There's some arrows to show that continues going on forever in both directions. Because remember, the domain is always access to the element of all real numbers. Okay, so I drew my parabola, Now I just need to identify where the x-intercepts are. X-intercepts. I have one here and one here at 1 and 0 and 5 and 0. Okay? Or we can say that our x-intercepts are x1, which is equal to 1, and x2, which is equal to 5. If I wanted to find out what my y-intercept was, I look right here. My y is negative 10. Okay, so we start with our vertex form. You might not have it in vertex form. Remember, it might be in standard form. So then what you need to do is just complete the square to put it into vertex form so that you can graph it. Okay, always put it into vertex form to graph. Then graph it, find out where the x-intercepts are. They're always going to be a whole number if we ask you to graph them. And then you write down your x1, your x2, and your y if we ask you for it. Okay? Graphing is a great way to solve if you have whole numbers. Okay? But what if I have the same basic parabola shape, but everything's just moved down 1? Everything is moved down 1. Okay? What are my intercepts now? Could be 1.25, could be 1.1. This one could be 4.9, could be 4.8. I don't know for sure. So we can't use graphing anymore. So we have to use one of our other two techniques. Okay, and the first one we talked about was solving by factoring. Okay. And this one, pretty straightforward, it's like it sounds. So set y equal to 0. Factor the trinomial. And then state your x-intercept. Or set them equal to 0. Okay, so in this case, what we're doing is we factor we set y equal to 0. Put it in the form of a trinomial if it's not already. Then factor it, set the factors equal to 0, and solve for x1, x2. So for example, if I were to have, let's say, 3x squared minus 4x, my parabola, sorry, it's y equals x squared, sorry, 3x squared minus 4x minus 32. Okay, if it's not done for you already, set y equal to 0. Because that is going to be where the roots of the quadratic equation are. Those are our x-intercepts at y equals 0. Okay, now I have to factor this. Remember, when we're factoring, make an AM chart. The numbers have to add to -4. Have to multiply 2, the last term, negative 32. I'm sorry. Have to multiply 2, 3 times negative 32, which is negative 96. So I need two numbers that add to -4 and multiply to negative 96. Whenever this number is a negative, your multiplied number is negative, you have one positive, one negative. The positive and a negative number. Okay, the factors of 96. One of the factor pairs is 8 and 12. Okay, 8 times 12 is 96. So one of them must be negative in order for it to be 8. Sorry, I said 8 and 12, not 8 and 96. 8 times 12 is 96. One of them has to be negative because the 4 is negative. That means that I'll have to have negative 12 and positive 8 to make up negative 4. Because if I do negative 12 plus 8, that's going to equal negative 4. Okay, so I have my two numbers, negative 12 and positive 8. Now I can factor them. Okay. Remember, order matters on tricky trinomials because 3 and 8 don't have a common factor, but 3 and 12 will. So 0 is equal to, I can factor out the 3 and the x, leaving with x minus 4. Then I can factor out my 8, leaving with x minus 4. Factor out the x minus 4, leave me with x minus 4. 3x plus 8 is my factor form. Okay. Now I'm not done yet. I need to set each of these to 0 individually. Okay. I'm just going to rewrite this over here. What I do is I set x minus 4 equal to 0, and I set 3x plus 8 equal to 0, because if either of these factors equals 0, so if x minus 4, whatever x by x is, as long as x minus 4 equals 0, the whole equation is going to be equal to 0 because 0 times anything is 0. Same principle for 3x plus 8. As long as 3x plus 8 equals 0, it doesn't matter what the other term or what the other factor is. If you get any number, it doesn't matter. It's being multiplied by 0. Therefore, the whole thing equals 0. Okay. Now I solve for each x. Bring the 4 over. I have x1 equals 4. I have 3x equals 8. Or negative 8. So x is equal to negative 8 over 3, and this is my x2. Okay, so my solutions are 4 and negative 8 over 3. Okay, so that is our second method of solving. However, not every trinomial is factorable. Okay, in fact, a lot are not factorable. If we can't factor a trinomial, that's always our gold standard of solving. It's solving by factoring. But if our quadratic function is not factorable, that leaves us with option 3, which is solve by the quadratic formula. Now, it needs to be in standard form for us to use this. If you don't remember what standard form is, it is y equals ax squared plus bx plus c. Okay? The quadratic formula you'll need to memorize. Well, you can write it on your summary sheet for the culminating, but for your exam, you need to memorize it. Okay? Quadratic formula is, remember the sum, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, that is our quadratic formula. So we have a, b, and c, and that is how we factor, or that is how we solve for x. Okay, the plus or minus here will allow us to have 2 roots if possible. Okay, sometimes you only have 1 root, sometimes you might have none, which we're going to talk about in just a second. Okay, but first let's do an example. So example, I have x squared minus 2x minus 5 equals 0. Okay, it's already, we already set the y equal to 0. So let's want to solve for this equation. If I were to do an AM chart, I need two numbers that multiply or add up to -2 and multiply to -5. Well, the only two numbers that multiply to 5 are 1 and 5. There's no possible way I can get 1 and 5 to add up to 2. So I can't factor it. Therefore, I have to use the quadratic equation. Okay. So x equals -b plus minus square root b squared minus 4ac all over 2a. Okay. My a, because x squared is all by itself, that means a equals 1. B is -2. C is -5. I'm just going to put all these right into my equation. So I have -2, which will just become +2 in the next line. Sorry, SmartForce frozen up. There it is. Brackets, b squared, -2 squared minus 4 times 1 times -5 all over 2 times 1 equal to 2 plus or minus square root of 4 plus 20 all over 2. Let's simplify this a little bit more. B is equal to 2 plus or minus the square root of 24 all over 2. If I ask you for an exact answer, that's your exact answer, okay? Because we're leaving the root as a root, we're not approximating it at all. Okay, so if I ask you for an exact answer, just stop there. Maybe you can simplify it a little bit because we can get rid of the 2 in the denominator, but as for an exact answer, I won't do that to you. It'll just be something like this, okay? But if I ask for an approximate answer, keep it going. X equals 2 plus or minus the square root of 24. Going to do it to one decimal place. Is 4.9 all over 2. Okay, now we have to break it up into x equals, this is the simplest you can make it before we have to split the plus and minus. So x equals 2 plus 4.9 all over 2, and x equals 2 minus 4.9 all over 2. Okay, so this is the stage where we break up that plus minus into just plus and just minus. And that will give us the two roots of the equation. Okay, unless if it's 0, in which case we only have 1. Okay. So if x equals 6.9 all over 2, and x equals negative 2.9 all over 2. So x equals 3.45 times 1. And x2 will be equal to negative 1.45. It doesn't matter which one I call x1, doesn't matter which one I call x2, just as long as I have them both there. So the solutions would be 3.45 and negative 1.45, approximately. I can change that to approximately. Okay, so those are the 3 ways we can solve. There's just one last thing, one last topic, and then I'm just going to tell you that there's going to be word problems as well. This bit right here is the last bit we have to talk about. That b squared minus 4ac. It has a special name. I'm sure some of you are yelling out what it is. It's the discriminant. So the discriminant, we say our delta for it, is equal to b squared minus 4ac. And what the discriminant does is it tells us both how many solutions there's going to be and the nature of the roots. Okay? So remember, quadratic equations always have two roots, but they might not always have two solutions. Okay? Because we can have a quadratic equation that's something like this. I can have a probably something like that. I can have one that looks like this, or I could have one that looks like this. Okay. In this case, I have two solutions. Okay. And in this case, my delta b squared minus 4ac will be greater than 0. So it's going to be a positive number. Okay, that gives me two real and distinct roots. And two solutions. I'm going to move these over a bit just so that I have space for my example. In this case, it comes up and I only hit the x-axis once. That will mean that my discriminant is equal to 0. But I still have two real roots. But the two real identical roots. Okay, it's the same root. Okay, because when I do the square root of b squared minus 4ac, it doesn't matter if I add it or subtract it, they both equal to 0. Okay, and I only have one solution. So this is the nature of the roots is real distinct, real identical, or number of solutions. How many solutions there are? Okay, this one, I never actually crossed the x-intercept at all, so I have no solutions because my discriminant is less than 0, the negative number. So I have two imaginary roots. And 0 solutions. Because there's no x-intercept at all. So let's do something like I want to find how many solutions there are of solutions for x squared plus 2x plus let's go 28. Go 29, that's all. Okay. I have x squared plus so my A is 1, my B is 2, my C is 3, or sorry, my C is 29. My delta equals B squared minus 4AC. So it's going to be 2 squared minus 4 times 1 times 29. So I have 4 minus 116. Yep. So my delta will be equal to negative 112. My delta is less than 0, therefore no solutions. And I have 2 imaginary roots. Okay? And we say imaginary root because it's the square root of a negative number, which is an imaginary number. Because if I were to plug this into the quadratic equation of x equals negative b plus or minus the square root b squared minus 4ac all over 2a. So I plug in everything. What I'm going to end up with will be negative b, or negative 2, all over 2 plus or minus the square root of my discriminant is negative 112. I can't have the square root of a negative number. That's why there's 0 solutions. Okay? And that's also why they're imaginary, because imaginary numbers come from the square root of a negative number, which you'll learn about in 11U. Okay? So that's everything for quadratic equations. The only other thing that will be coming out of this unit are word problems, okay? Just so you don't forget. Word problem, run out of space. Word problems. Okay? So again, it could be like maximization, it could be we could be looking at like length and width and calculating area. It could be finding 2 numbers that are factorable. It could be anything. Okay. So those are the last thing that you'll need from this unit, and that actually wraps up our whole review. Okay. So remember, culminating part 1 is tomorrow. Turn on the camera now. Culminating part 1 tomorrow. Stop presenting. If you need help, you can send me an email tonight, and I'll help you out with any questions that you might have. And you can come in tomorrow at the beginning of lunch. That'll be 10:45. You can come in anytime then and start your test. Okay? That way you have lunch plus our whole period, because as soon as the bell rings at 12:50, I have to collect it because it's a summative assessment. Okay? So again, any questions, send me an email tonight, and I'll see everyone tomorrow. Okay? Good luck. Bye. Wait, stop recording. Now bye.